This is Dr. Y.S. Rao. So, in the previous sessions, we have used the sensors, infrared sensor, switch as a sensor, and the infrared sensor we have used for obstacle detection, line follower, and we also used the sensor, which is light dependent resistor (LDR). LDR is analog sensor where the output voltage changes between 0 to 5 volts based on the intensity of the light. We will use one more sensor which is there on the board. Then we will think of some case studies, applications. The final sensor you can notice which is there here, that is 13, what is written as a 13 TSOP sensor, TV remote, right? It's sensible to the remotes which we use for televisions. Otherwise, we have seen the remote controlled in air conditioners also, or some music players, right? Several applications nowadays. Lights also can be controlled on and off with the help of the remote controls. So it is a sensor which is depends on the infrared light IR. However, there is a difference. The infrared sensors which we have used for obstacle detection, but this sensor, infrared sensor, the working principle, though it is a infrared light spectrum, but working principle is not same. Let's see in what way it differ. Right. So in the previous session we have done LDR, light dependent resistor. What is the sensitivity of that sensor is a visible spectrum. You can see the visible light. So for any signal, right, what is important is, right, the signals as a physics, as a science point of view, you need to understand the nature of the signal. So generally we see the nature of the signals either in terms of wavelength, the length of the wavelength, that's called radiation type, electromagnetic radiation type, or the frequency of the signal, and the third is the amplitude of the signal. So these are the three things which will indicate the behavior of some physical parameters. So still if you see, for example, visible light falls between ultraviolet frequency and infrared frequency. So it is somewhere here. But if you see the infrared light, the one which we are talking right now, falls between microwaves. That means if you see the wavelength, it is smaller than the microwave lengths, but at the same time slightly bigger than as compared to the visible light. So it falls between microwave length and the visible spectrum. So that's the property, because see, finally the wavelength, frequency, amplitude we are representing the some physical phenomena, and in this case in our application, infrared sensor looks like this, what is called TSOP1838, mainly used for TV remotes, right? It's a receiver, please remember this is a receiver, and the transmitter is there on the TV remote itself. So whenever you press any button on your TV remote, which is a transmitter, it will emit the light. However, here the light emission is not just a 0 or 1. As you can see, it is a bunch of pulses. You see how many pulses it is transmitting, right? I mean, if you carefully look at, there is a big pulse of 9 milliseconds, and then half of it is a 4.5 milliseconds low state, and then there are a bunch of pulses, 8 pulses, what is called address, another 8 pulses called another address, which is called logically inverted, means opposite to this. Then another 8 bunch of pulses, what is command, and logically inverted, means opposite to this inverted form. So 8 plus 8 plus 8 plus 8 plus 9 milliseconds of high state, 4.5 milliseconds of low state consist of one key press. So that's the beauty you need to understand. So whenever you press a key, these many, that means total 67.5 milliseconds duration bunch of pulses will be transmitted. So naturally this fellow, which is a 3-pin sensor, there is a VCC ground signal. So it will receive the signal, and this signal is actually how the signal is nothing but output pin. How the signal is generated. Whenever this detector, means this fellow, detector receives the signal from the TV remote transmitted signal, there is a lot of process like a input amplifier, automatic gain control, then there is a filter, then there is a demodulator. So all these stages actually called signal conditioning. So the signal will be processed, and finally these pulses are available. And the pulses, you should remember what is called carrier frequency, means their frequency is 38 kilohertz, that means 26.3 microseconds is the one pulse, that is the on time and off time. One pulse is the frequency of the pulse, is duration is 26.3 microseconds. So this is called carrier frequency. With this frequency, means at 38 kilohertz, these bits are transmitted. So why that frequency? Because as I said, finally we would like to use the infrared light spectrum, which is not visible spectrum, right? This is not visible. All right. So there is a what is called protocol, IR transmitting protocol. That means whenever you press any TV remote, as I already discussed, that the each pulse burst is of 562.5 microseconds length, and the frequency of that pulse is 38 kilohertz. So whenever you want to transmit, let's say logic 0, means low state, then this 562.5 microseconds pulse followed by another space of 562.5 microseconds with a total of this plus this, means 1.125 milliseconds represents logical 0. Logical 1 means again 562.5 microseconds pulse followed by 1.6875 milliseconds of space with a total transmission time of 2.25 milliseconds. So logical 1 is, as compared to this, almost a double duration as compared to logical 0. So that represents logical 1. So that the 9 milliseconds leading pulse burst is your starting. If you remember, this 9 milliseconds is the starting period. Then followed by 4.5 milliseconds is the space. So 4.5 milliseconds is the space. Then total how many bytes are transmitted? 4 bytes. 4 bit, 8 bit, 8 bit, 8 bit, 8 bit. This is one 8 bit, second 8 bit, third 8 bit, fourth 8 bit. So what do they have? This is the address, right? Address of the receiver. And then the same address is a logically inverted, means complementary, means 0 will become 1, 1 will become 0. That will be, so 8 plus 8, 16 pulses represents the address. Then again 8 bit is a command, and reverse of this, inverse of this will be inverse of the command is another 8 bit. So these 16 bits represents the command, means identification of the key itself. So that is how the total duration is 67.5 milliseconds represents any one of the key. So as you press a different keys, instead of 1, if you press 2, 3, escape, equal, whatever you press, accordingly the command, because see how many bits you have for commands, 8 bit. So 2 to the power of 8, that means 255 possibilities are there. That means as if you can have 255 switches. And what do you mean by address? Address means such type of receivers, if you have 8 bit, That means you can have 255 receivers in a room. So then it will differentiate. Say for example, if you are operating a TV, your neighboring another infrared receiving device won't be affected because that may be having a different address, right? For example, your air conditioner is also there, your TV is also there, your set-top box is also there. But every device has their own logical address, and within the remote also every key has a different kind of a command. So when you receive this, so 2 to the power of 8 plus 2 to the power of 8, so that means 255 possible devices, 255 possible commands. You can decode it. All right. So like I was telling, what do you mean by carrier frequency? Carrier frequency means whenever you are sending a logical one is nothing but a bunch of pulses. So this logical one consists of, let's say, 38 kilohertz burst pulses will be transmitted, which represents logical one or logical zero. See, means they are using particularly a frequency which is of a high frequency so that it won't be visible. Right? So like I was telling, I mean, what do you mean by protocol? A protocol is nothing but which consists of address field, data field, there may be a start bit, there may be a stop bit, so that this whole thing is called as a frame. Whenever you press a button, one particular frame will be transmitted. So while receiving, your receiver has to decode this and try to find out the meaning of this, and then accordingly you can do some action. So let us see, let's write a program, right? The programs are there in folder number 10, IR remote sensor. So it's a remote sensor, means remote means TV remote sensor. So if you look at this program, now let's say we want to display, we are using LCD because whenever you press any TV remote key on LCD, we want to display which key you have pressed, right? You have several keys, so we'd like to display so and so key is pressed. So that means when you, after initializing the LCD, the variable we want to display it on the as a IR input, right? Now we have defined the variable is a, like we said earlier, there are several possibilities of variables. In this example, we are using your TV remote. While could be a conditional loop. So right now we are using a conditional loop so that if whenever a some key is pressed, TV remote key is pressed, then it will receive the value and it will come out of the loop. That means we are interested only one key press. Till then it will be in the loop, unless if some key is received, it won't come out of the loop. So as soon as the key is pressed, it will, the variable, it will store it and it will come out of it. So since the value is stored, assigned, stored internally, and when it comes out of the loop on the LCD, it will display, right? What we said, the variable LCD output type is a variable we have selected instead of a text, and output variable, we have several variables we can display, but we are interested in displaying the infrared, right? TV remote variable, we would like to display it on the LCD. So let's see how the program behaves. So the program is loaded, right? So you can see the TV remote sensor next to the USB is there with a metal sheet covered, encapsulated. Now I'm using the TV remote. You can use the one which you are also having in the laboratory. And you can see the white LED. This is transmitter. The black one which is there on the PCB is the receiver. Now the program is loaded. Now you can see it's the message is displayed saying that press the switch. Now if I press any button, now I'm pressing. Okay, let me see. See, now the code 4, I have pressed the button number 4, code 4 is displayed and it came out of the loop. That's why the buzzer beeped twice and it came out of the loop. That's how the program is written. That means it will display only one key. But if I want to again read the key press, I don't need to load the program again, because as I told you, there is a switch here called restart the program, reset button. So if I press the reset button, now see again my program is restarted. Again it is waiting for the key press. Now this time I will press some another key. See, now the key is recognized. The new code is displayed on the LCD. So like that, as you keep on uh, pressing the different switches, the corresponding key code will be displayed on the LCD. However, it's not just reading one key. You can make this for reading the multiple keys, and then accordingly you can switch on or switch off the LEDs, or you can switch on the motors, right? Instead of using the LCD, you can use the motors to move the motor forward, backward, so that the vehicle can be controlled with the help of a remote, right? You can use the you have the buttons on your uh, remote for forward, backward, reverse, left, right. Accordingly, you can define in the program saying that we have seen the conditional statements. If, right, if so and so, for example, you can see if IR sensor is detected, then compare the value and take some decision to move the motor left side, right side, forward, backward. Remotely also, with the help of TV remote also you can control. So with this, we have completed almost all the features of the QU board, whatever is fabricated. We can also interface, but some new devices, but that we will do it some in other course where we have specially designed for interfacing some new sensors, new controllers, or even new programming languages, including embedded C, Python language, and all. This is just a beginner's compiler. As you know, though we are practicing all possible syntax, but without writing the code, because we are using the graphical symbols. Even nowadays also, the some companies are providing GUI based compilers, right? So it's a choice. Visual lab, what's called a okay, so maybe in the next session, we will demonstrate some of the projects. So where are the projects are there? The project examples are there in application codes. You can see there are more than 13 application codes are there, like IR remote control, line follower, hand follower, edge avoider, distance measuring, sensor line follower. So many examples are there. I wish you also should modify these programs and do it as per your wish, right? For example, IR remote control. You see such a beautiful program where based on your this thing uh, uh, infrared sensor, right, value, right? For example, have you pressed 32 key, have you pressed 33 key, have you pressed 17 key, 16 key, because every key has some value. Then what are you saying? Oh, if this key is pressed, so and so motor should be forward with this speed. So and so key is pressed, move backward. So and so key is pressed, move the robot left side. So and so key is pressed, move the robot right side, and so on. All right, so these are all such a beautiful programs. You should try it, and also you should modify the program so that you create your own project and do that. That will be more useful because you have some logic in your mind, and that logic you have converted into a program form, and then you are able to demonstrate it. The reason for why we have started with QU board is because even if you do not have any knowledge about the programming languages, but here the advantage is you can physically visualize Otherwise, simply if you write the code and whatever is displayed on your computer monitor, most of the time you are not sure, right? I mean, what are the applications, right? Why I'm using these different types of conditional statements, right? Different operators and so on. Because of this kind of a robotic programming, now you understood that actually in real products how this software works. All right, so thank you for listening and attending this entire course. Maybe I will conduct one more session or maybe a few more sessions related to the applications. All right, thank you. Bye bye.